The indecision archetype is another relatively simple structure that produces rather unexpected behavior. It begins with a result which, through action and interaction with another result, tries to move this result in the direction of result 1. So it's essentially a goal-seeking structure where result 1 is the goal and result 2 is the current state, and the action attempts to move result 2 in the direction of result 1. Though what happens is, or the rest of the structure is, that result 2 just happens to be the goal interacting with result 1, attempting to move result 1 in the direction of result 2. So it's sort of like a drifting goal structure, though where it differs is that there are typically two delays that are actually different from each other that causes it to act more like two goal-seeking structures with delays that are out of sequence that produces rather unexpected behavior. When I implement this as a stock and flow simulation model, and I've added a delay 1 and 2 so that I can actually vary the delays so that they're not the same, and I've added a factor here so that I can control the extent to which the two delays actually interact with result 1 and 2. When I go ahead and initially simulate this with result 1 and 2 being slightly different than each other, and there being no delay and a relatively small factor, it behaves as one would expect two drifting goal structures where result 1 drifts from where it was down to, I don't know, about 7.5, while result 2 is attempting to reach result 1, but they end up stabilizing at 7.5. So it looks like a drifting goal structure. Though if we increase the delay, actually add some delay, and we increase the factor so that the interactions are happening more aggressively, we notice we begin to get the damped oscillation behavior that we saw from the drift or the goal seeking with delay, though not only is because there are actually two results which are the goals of each other, both of them are oscillating back and forth as opposed to simply one state oscillating back and forth as it was with the goal seeking with delay. Now, as we continue to increase the delay in this structure, notice that the time that it takes for the damped oscillations to actually settle out are longer and longer. And if we were to increase the intensity with which the factor actually interacted with the structure, you could actually cause the structure to be out of control, the same way that the goal seeking with delay structure could be out of control. So it's the way this structure behaves is due to the delays in the structure, so that it's like you have a goal and you pursue that goal, but by the time you get there, the goal is somewhere else. And you then have to go do some reverse action to end up chasing the goal. But the difficulty is that the goal that you're chasing is also chasing you. So it goes back and forth. There's a couple of examples provided in the references for this lecture. One has to do with blackbirds and grass-eating worms, so that the blackbirds are annoying, so that the choice is to kill blackbirds, reducing the blackbirds so that they're not so annoying. But when you kill the blackbirds, they don't eat so many of the grass-eating worms, which are harmful, so that people decide that they want to kill more blackbirds. So this oscillates back and forth, back and forth. And the other example provided has to do with economics. It's the way that supply and demand typically oscillate back and forth between price, so that based upon a given supply and demand, there's a price established, which causes consumption to change and production to change, and once consumption changes, it causes the price to change. When the price change causes production to change, changing the supply, which causes the price to change. And because of the delays in this structure, it tends to oscillate back and forth also. So I hope you found this video of interest, and I'll see you in the next video. Bye.